Welcome to Pi Engineering. In this session, we will see about the power series. A power series is a series or an infinite series given by n runs from 0 to infinity of an into x minus n raised to n for all x for all x if x is any variable an infinite series given by this form is called a power series. In this expression a is called center of power series. A is center of a power series. This means to find the center of the given power series, we have to equalize x minus a with 0, which gives x equal to a. So a is a center of power series. Let us see this with an example. A summation as n run from 0 to infinity of 3x minus 2 raised to n over n. In this part or in this infinite series, we have center which is equal to 2 over 3. This means we find the center of the given series by equalizing 3x minus 2 with 0. This results in x equal to 2 over 3. So the center of the given series is 2 over 3. Let's see another example. B summation as n run from 0 to infinity of 5 into x minus 2 raised to n. Here we have center which is equal to 2. The third example, C summation as n run from 0 to infinity of x power of n over n factorial. Here the center of the given series will be 0. Here, because we have no any subtrahend here, in place of a, it is 0. X minus 0 raised to n is equal to x raised to n. Next, we will see about how to find the radius of convergence and the interval of convergence of this given series. Okay, to find the radius of convergence and the interval of convergence of the given power series, the two methods, the generalized root test and generalized ratio test would be employed. This is to find radius of convergence and interval of convergence of the given power series. Okay, in this session, let me use a generalized ratio test to find the interval of convergence and the radius of convergence of the given power series. Okay, let me start by defining the generalized ratio test. Generalized ratio test, I mean by GRT, generalized ratio test. So the expression for generalized ratio test is limit of n absolute value an plus 1 over an as n runs to infinity. Here we have important three cases. important three cases we have to follow depending on the result of this generalized ratio test. The first case is if limit of the given generalized ratio test as n goes to infinity is equal to 0, what will happen? Then the series converges for all x. This means the radius of convergence is equal to infinity, whereas interval of convergence is from negative infinity to positive infinity. If the given generalized ratio test results in 0, the radius of convergence is infinity and the interval of convergence is from negative infinity to positive infinity. And the second case is if this generalized ratio test limit over an as n goes to infinity is equal to infinity. What will happen if the result of our limit become infinity? Then the series diverges for all x. The series diverges for all x except at one point which is the center of the given series except at x equal to c. This here c means the center of the given series. So let's another one case we left. The third case is if the result of the given generalized ratio test an plus 1 over an as n goes to infinity become 1 over r times x c, which is less than 1. Here this one, then we use this expression to find the radius of convergence of the given series. From this we have absolute value of x minus c less than r, because r will be multiplied by 1. Here, whatever number you get here is the radius of the given power series. The number you are going to find or get from this expression will be the radius of the given power series. But what I mean by this? This means absolute value of x minus c is less than r. If this is true, the power series will converges. But if absolute value of x minus c became greater than r, the power series diverges. So we will find the radius of convergence and interval of convergence of the given series depending on whether the absolute value of x minus c is less than r or absolute value of x minus c is greater than r. From this we have absolute value of x minus c less than r. This means minus r is less than x minus c is less than r. This result is in minus r plus c is less than x is less than r plus c, r plus c. So from this, the interval of convergence is equal to negative r plus c comma r plus c. In our initial cases, we said, or we have seen if x minus c is less than r, the power series converges. But if x minus is greater than r, the power series diverges. So since we are looking for the radius of convergence and the interval of convergence of the given series, we have to consider this part. And by considering this part, we have two results, minus r plus c and minus r plus c. So the interval of convergence become this part. Okay, in this case, there might be four cases we have, because interval of convergence may be closed bracket r plus c comma r plus c close bracket. This means r minus r plus c comma r plus c, both endpoints will be included. Another case is if interval of convergence become closed bracket minus r plus c comma r plus c open bracket. In this case, minus r plus c will be included, but r plus c will be excluded. And third case will be interval of convergence may be open bracket minus r plus c comma r plus c close bracket. In this case, minus r plus c will be excluded from the interval of convergence, and r plus c will be included. The fourth case will be both open bracket r plus c comma r plus c, if both endpoints will be excluded from the given interval of convergence. So we have to consider all those four cases while we find the interval of convergence of the given series when the result of the generalized ratio or root test result is in this third case. Here, in general, if interval of convergence became a comma b, then with possible inclusions of the endpoints, the radius of convergence became b minus a over 2. b minus a over 2 will be the radius of the given power series. Okay, thanks for watching. In the next video, we will see an examples of radius of convergence and the interval of convergence. Don't forget to subscribe to my channel, and if you think this video is useful for others, please don't forget to share to your friends. If you have any question, you can put it in a comment section, and thanks. We will see in the next part.